Hey guys, Mr. Larson here. Wanted to run through 6.1 notes with you. It's a law of sines. It's real quick notes today. Other than the warm-up, there's really like one equation that we're going to use, and then we have two examples solving a couple triangles. All right, so if you want to go ahead and pause, and you can try to do the two warm-up problems here. First one will be calculator. Second one's just trying to pull from memory. All right, so find all values of x between 0 and 360 if the sine of x is 2/5. Okay, so this is a calculator problem. So if you guys remember, it hasn't been that long, right? The sine of x is 2/5. So x is our angle, and the sine of that angle is 2/5. So if you want to undo that sine function, we have to do the inverse of it, which of course is inverse sine. So inverse sine and sine offset each other, and I'm left with x is equal to inverse sine of that fraction 2/5. Now remember, 2/5 is a positive sine value. Well, sine is like your y value, right? So we're going to be positive in quadrants 1 and 2. And going into this, before I do the calculation, the calculator is going to spit out one correct answer for me, and then I'm going to find the other angle that has the same reference angle as the first angle that I get on the calculator. So we're going to be in degree mode. So degree mode, and we want to do inverse sine of 2/5. Okay, so that gives me 23.58 degrees. So there's one of them, and that looks like it's my quadrant 1 angle, right? So this is 23.58 degrees. By the way, that reference angle is also going to be 23.58 degrees. And that tells me that the reference angle in quadrant 2, I know that's real tight there, is going to be 23.58 degrees. So I want to do 180 minus that reference angle to figure out my quadrant 2 angle. Let's see, 23.58. I'll show you my screen here in a second. Okay, so 156.42. That does land in quadrant 2, so that checks out. Okay, so there's my two angles. Not bad, not bad. Okay, so next you're going to remember back to probably freshman year, whenever you took Math 1, your geometry unit. What are the 4 shortcuts to proving that two triangles are congruent? Remember, there's 6 pieces in each triangle. There's 3 legs and 3 sides. And if you can prove that a group of 3 in the first triangle are congruent to a group of 3 in the second triangle using one of these shortcuts, then you've proven that the two triangles are congruent. So you may remember these after I list a couple, but side angle side is one of them. Side 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 is another. Angle side angle is one. And then angle angle side. Common one that people write that's incorrect is angle angle angle. That proves similarity, not congruence. And then another one is angle sides. Oh, I should probably not write that like that. Angle side side, or side side angle, right? That's not enough to prove congruence either. We're going to actually do an entire note session next time on side side angle. It's called the ambiguous case. Sometimes you get, well, I won't get too deep into it. You will have some examples in your practice today that are side side angle, but just trust that you'll end up in the right spot using law of sines. The complicated stuff will be the examples that we see next time. Okay, so what is the law of sines? The law of sines is an equation that we can use that shows a relationship between angles and sides in any triangle. So it's pretty cool. So Here's for triangle ABC, we have the sine of A over A is equal to the sine of B over B. So if you take one of your angles, take the sine of it, and divide it by the side across, that ratio will equal the sine of a different angle divided by the side across from it. So of course this will also work for C. So the sine of C over C. So keep in mind here that any capital letters represent angles, and across from that will be the lowercase of that same letter, and lowercase represents side lengths. So angle C is across from side C, angle B across from side B, so on and so forth. Okay, so lowercase is sides, capital is angles. A couple other things to note that'll help us out. Your largest side is always across from the largest angle. So in the course of solving these problems, if you get something else, if your largest side is across from your smallest angle, then you did something wrong, right? So smallest side is going to be across from the smallest angle, and same with the middle one, right? Middle side will be across from the middle angle. Middle in size is what I'm talking about. Another thing, just remember that all three angles will add to 180 degrees inside of a triangle. Hopefully you guys remember that. So you may be asked to solve the triangle. Solve means find all the remaining sides and angles. Usually you're given 3 and you have to find the 3 other ones. Sometimes we'll just ask for one piece of information. So obviously if we're asking for one piece of information, that'll be a quicker problem. But on these 2 examples, we're solving the triangle. We're going to find everything that's missing. So you can't really do these without sketching a picture. So triangle ABC, it doesn't really matter where I put A, B, and C. I tend to always put B on the top, A on the left, C on the right. It doesn't really matter. You could have these in a different orientation than what I do, but what does matter is that you do correctly label the measures. So angle A is 40 degrees. Side A, which is across from angle A, is going to equal 4, and then the measure of angle B is going to be 60 degrees. So we need to find angle C, side B, and side C. Now, without using the law of sines, I should be able to find angle C pretty quickly, right? I know A, B, and C have to add to 180. I have 2 of them that already add to 100. So angle C, the measure of angle C, is going to equal 80 degrees. Please don't write please don't only write the answers inside of the diagram. Make sure it's like got a box separate. Box your answers separately, because it's a nightmare to grade if I have to look at your diagram and you got these scribbles everywhere. Okay. All right. So in order to use the law of sines, the reason we went over these shortcuts is you have to either have angle side angle or angle angle side. And again, you'll see that this one also works with law of sines when we get to the practice. But on these notes, it's either angle angle side or angle side angle. So this scenario here, the information I was provided with for example 1 is angle, angle, and this side over here. That's angle, angle, side. In order for that to be angle, side, angle, I would have had to know this side here because that's sandwiched in between angle A and angle B. All right, so side A over here is not an included side. So it wouldn't be angle, side, angle. It'd be angle, angle, side. So I'm not going to necessarily ask you that, but it's good to know that that's angle, angle, side. All right, so visually, you must know an angle measure and a side length across from it, and then one other piece of information. So I know 40 degrees, I know 4, those are across from each other. I know a capital and lowercase a. And then I have one other piece of information. So this lets me set up this equation. The sine of angle A, which is 40 degrees, over 4, is equal to, and I could find side B or side C first. I'm going to have to do them both. Let's do B because it comes first alphabetically. Sine of 60 degrees over B. Let's cross multiply. Let's divide by the sine of 40. And let's see. Make sure you're closing parentheses. So sine of 60, close parentheses because you're done with that angle, and then divide by the sine of 40. So I get 5.39. All right, let's do another law of sines setup. So I know 5.39. Now I want to find side C. So I'm going to use that same information I started with, the sine of 40 degrees over 4. I know those are accurate because they were given. I would try not to use this new side I just found, 5.39, although you could. But I'm going to use sine of 40 over 4 is equal to sine of 80 over C. Cross multiply. Divide by the sine of 40. And we get 6.13. And that's it. My pen is acting up. 6.13. Okay. So last example, same thing, set up a triangle. ABC, 35 degrees, 15 degrees, C is 5. This is now side angle side, because this is angle side angle, because I know the side that's included in between the two angles. I have kind of a freebie here, right? 15 and 35 is 50. Subtract that from 180, and I know that this is 130 degrees. Measure of angles. Angle C equals 130 degrees. And then from there, I can set up my law of sines. So I have my angle and side across, so that's my first fraction. And then pick which one you want to find. I'll find side A first. So sine of A over lowercase a, cross multiply. Divide by sine of 130. Close your parenthesis. That's a common mistake where you lose basically 3 points. And we get 3.74. Okay, let's start with that same fraction, that sine of 130 over 5. Let's set it equal to my other pair. So now I'll do sine of 15 degrees, which is angle B, over side B. Cross multiplying. And finish that, and what do we get? That was 1.69. So I'll let you guys do that math. Okay, so the last thing I'll say is just verify. I think you can see from this example one that the largest side is across from the largest angle, smallest side across from smallest angle, and that just confirms logically that our triangle makes sense. All right, guys, hope that helps. Thank you.